So, hi, I'm Wilson Alginhara from IT2103. So, welcome to my channel. So, first, we have here an activity from the chapter 7, which is Packet Tracer, Investigate Unicast Broadcast and Multicast Traffic. So, the objectives: Part 1, generate the unicast traffic. Part 2, generate the broadcast traffic. Then, Part 3, investigate multicast traffic. So, the background and scenario. This activity will examine unicast, broadcast, and multicast behavior. Most traffic in a network is unicast when a PC sends an ICMP echo request to a remote router. The source address in the IP packet header is the IP address of the sending PC. The destination address in the packet header is the IP address of the interface on the remote router. The packet is sent only to the intended destination. Using the ping command or the add complex PDU feature of Packet Tracer, you can directly ping broadcast addresses to view broadcast traffic. For multicast traffic, you will view EIGRP traffic. EIGRP is used by Cisco routers to exchange routing information between routers. Then routers using EIGRP send packet to multicast address, which is 224.0.0.10, then which represent the group of EIGRP routers. Although these packets are received by other devices, they are dropped at layer 3 by all devices except EIGRP routers with no other processing required. So, from the part 1, which is generate the unicast traffic, then from step 1, just click the PC1 and click the desktop tab, then command prompt. So, click the PC1, then the desktop. So, the desktop. After that, the command prompt, which is this. Then ping the 10.0.0.3.2. Then so the ping should be succeed. So 10.0, oh, I'm wrong. Again, ping 10.0.3.2, then enter. So the ping is succeed. Then let's proceed from the step 2, which is enter simulation mode. Then so click the simulation mode. Then click the simulation mode, then click edit filters. Then after editing the filters, then verify that only ICMP and EIGRP events are selected. So it's correct. Then exit this. Click the PC1. Click the PC1 and enter ping 10.0.3 command. Ping 10.0.3 command. 10.0.3 enter. So as we can see, we have here the from 10.0.3.2 with 32 bytes of data. So after that, the PDU at PC1 is an ICMP echo request intended for the serial interface on router 1. Click the capture forward repeatedly and watch while the echo request is sent to the router 3 and the echo reply is sent back to PC1. Stop when the first echo reply reaches PC1. So click the capture forward, then this. So after that, and watch while the echo request is sent to router 3. So capture forward, then capture forward. Then as we can see, the ICMP is in the router 3. So let's proceed to the next one. So stop when the first echo replies reaches PC1. Then after that, which device did the packet travel through with the unicast transmission? So the unicast transmission are travel through the switch, and the next one is from the is going to the router 1, then going to the router 3. After reaching the router 3, the ICMPV are going back to the router 1, then going back to the switch, and then going back to the PC1. So in the simulation panel event list section, the last column contains a colored box provided Colored box provides access to detailed information about the event. Click the colored box in the last column for the PDU first event. The PDU information windows open. So this is the event. So we have to click the last one, which is this. Then we have here the 3 layers of the event. So after that, what layer does this transmission start at and why? It starts from the layer 3, then the layer 2, and for the layer 1. Then examine the layer information for all the events. Notice that both source and destination are unicast addresses that refer to the PC1 and the serial interface on router 3. What two changes take place at layer 3 when the packet arrives at the router 3? So from the layer 3 IP headers, source IP 10.0.3.2. So the destination IP is 10.0.0.2 ICMPV message type 0. Then when it comes to layer 2 in Ethernet to header, it changes 00EO, then 8398.001, then D001.646C, that 4136. From the layer 1 is for port fast Ethernet 0. Then after that, click the simulation. Then step 1, add a complex PDU. So add a complex PDU. The icon for this is in the right toolbar and shows an open envelope. So from the part 2, we have to click add complex PDU. The icon for this is right tool shows the open envelope, which is this. Then after we click that, float the mouse cursor over the topology and the pointer changes to an envelope with a plus sign. So just like that. So after that, click PC1 to serve as the source of this message and create complex PDU dialog window opens. Enter the following values. Then this, this IP address, which is 255.1, from the sequence number is 1, then from this destination is 255.255.255.255. Then let's see, destination IP and the sequence number is 1, then the one shot is 0. Then after that, within the PDU settings, the default for select application is ping. What are the list of other applications available for use? That's this. Then click the create PDU. This test broadcast packet now appears in the simulation panel. Event list also appears in the PDU list window. It is PDU for scenario 0. So this one, then that. So as we can see here, so click capture forward twice. This packet is sent to the switch and then broadcast to PC to PC3 and the router 1. Examine the layer 3 information for all the events. Notice that the destination IP address is 255, which is the IP broadcast you can trigger when you create the complex PDU. So analyze the OS model information. What changes occur in the layer 3 information of the outliers column at router 1, PC2, and PC3. So click the social simulation. So click this, then this, then this. So why click capture forward again does not work as video ever forward onto router 1 on router 3. Why? So after you're done examining the broadcast behavior, delete the test packet by clicking delete below scenario 0. Delete.
Major differences in delivery.
So from the part 3, which is examine the contents of these packets by opening PD information window by click capture forward. Again, the packets are sent to the two other routers, which the routers accept to process the packets because they are part of the multicast group. The switch will forward the packets to the PC. So click capture forward until you see the EGR packet arrives on the PCs. What the host do with the packets. Examine the 3 layers for information for all IIGRP events. So what is the destination address of each packet? Then click one of the packets to one PC. What happened of those packets? So this. Then based on the traffic generated by the 3 types of IP packets, what are the major differences of delivery? So I think we're done for this chapter. So thank you for watching.